Hello everyone. Today we are starting a brand new series on algebra and numbers, and we are kicking things off with the absolute foundation, factors of natural numbers. Now, whether you are splitting up group of members for a project or dividing a pizza equally or working with the complex algebraic formulas later on, factors are behind all of it. By the end of this lesson, you'll master factor pairs, factor trees, special number types, and some really cool numerical tricks. Grab your notebook and let's dive in. Before we write down any definition, let me ask you a simple question. Why do factors matter in the real world? Imagine that you are a teacher with 12 students and you want to arrange them into perfectly equal rows. How many options do you have? Well, you can put them in one row with 12 people long, or two rows with 6 people, or three rows with 4 people in each. Notice how every single arrangement forms a neat, complete rectangle with nobody left out. Okay? That's the real idea of equal sharing. Without any reminder is exactly what factors are all about. Now let us test this with a bigger number, say 24. So here you can see we can write 24. We can make a rectangle that's 1 unit tall and 24 units wide. Or we can transform into two rows of 12 people each. Or we can transform into 3 rows of 8 people each. Or we can transform into 4 rows of 6 people each. So here you can observe rows into column gives us a total objects. In every example you can see rows into column gives us a total objects. Those are the length. Those lengths are, we can see here, 1, 2, 3, 4, 6, 8, 12 and 24. I'll repeat once again. You can see these lengths are 1, 2, 3, 4, 6, 8, 12 and 24. These are the factors of 24. So, how do we define a factor mathematically? Simply put, a factor is a natural number that divides into another number cleanly, leaving zero remainder. Okay? Let's test this with the division machine using a number 24. So here 24 can be divided by 2 and gives us a 12. So it doesn't give any remainder, so it's a factor. And 24 is divisible by 3 gives us 8 and it's a factor because it doesn't give any remainder. But if we divide 24 by 5, we get the 4 and 4 as a remainder, so it's not a factor. And if 24 is divided by 6, we get a 4. So it's a factor. Here you can see 5 is not a factor of 24. The rest of all are factors of 24. Remember that if there is a remainder, it's not a factor, as simple as that. Now, how do you make sure you never accidentally skip a factor on a test? You use factor pair method. Let's find factors of 36. So always start with 1. So 1 into 36 is nothing but 36. And next try 2. 2 into 18 gives us 36. How about 3? 3 into 12, 36. Try 4. 4 into 9 gives 36. And for 6 into 6 we get 36. So now here you have to stop because it's a signal that you are completely finished. Because you got duplicate values, like 6 into 6 is a perfect square, so you have to stop here. So we get the factors are 1, 2, 3, 4, 6, 9, 12, 18 and 36. In this topic you are going to learn about factor pairs and factor tree. So I see students mix these two up all the time. So let us clear it up. On the left you can see factor pairs. List every single number that divides 24. On the right you can see factor tree of 24. it down into ultimate building blocks. It's a prime factor. So here you can see we get the factors of 24 as 1, 2, 3, 4, 6, 8, 12 and 24. So total number of factors here we get are 8. And whereas in prime factor tree, we are breaking down this number 24 into building blocks, prime building blocks. I mean 24 is a multiple of 2 into 12. So next here 12 is a multiple of 2 into 6. Then here 6 is a multiple of 2 into 3. So here we can see 3 times 2, I mean 2 cube. And at last you get 3 into 3. 2 power 3 into 3 is nothing but it's a prime form of 24. Here 2 power 3 is nothing but 8. 8 into 3 is nothing but 24. So we write this prime factor tree as 2 power 3 into 3. Factor pairs list every possible factor, whereas prime factorization breaks a number down into prime building blocks. Okay. Depending on how factors a number has, we group them into special categories. Let's flip this. So here you can see prime number 13 has only 2 factors, that is 1 and itself. And composite number 18 has more than 2 factors. Those factors are 1, 2, 3, 6, 9 and 18. And perfect square like 16 or 25, we get odd number of factors because the number is repeated twice, so that we get only odd number of factors. So here factors of 25 is nothing but 1, 5 and 25. And perfect cube 27. 27 comes from multiplying the same integer 3 into 3 into 3. That's why we get 3 cube. So factors of 27 is nothing but 1, 3, 9 and 27. So remember, the number 1 is unique and it is neither prime nor composite because it has only one factor. Here is a brilliant mathematical secret you can use on exams. Take a look at this table. In this table, you can see the number 16 has an odd number of factors. These factors are 1, 2, 4, 8 and 16. So it's a perfect square. Remember, always a perfect square always has a odd number of factors. And for 18 you can see even number of factors. Those factors are 1, 2, 3, 6, 9 and 18. These are even composite number because 18 is a composite number, so it is an even composite number. And for number 19, we can only see 2 factors, that is 1 and 19. So it's a prime number. Prime number is always has only 2 factors, that is 1 and itself. So this 19 is a prime number. Likewise 13 also you can get. I mean 13 has only 2 prime numbers, that is 1 and itself. Okay. And for 20 we have 6 factors. 6 factors. Those factors are 1, 2, 4, 5, 10 and 20. Here we have multiple factor pairs. Okay. And for 25 we get odd number of factors. Those are 1, 5 and 25. As we all know, 25 is a perfect square. Only perfect squares has a odd number of total number of factors because one factor pair consists of identical numbers. Okay. Can you find all the factor pairs of 48? Pause this video right now if you need extra time or beat the clock on screen. Your time starts now. So we are revealing this factor list. So here is answer. So all the factor pairs of 48 is nothing but 1 into 48, 2 into 48 or 3 into 16, 4 into 12, 6 into 8. That's total number of 10 factors we have. Did you get them all? Please check it out. Let's do 3 more quick practice problems to build up your speed. Find the factors of 30, 42 and 64. Pause this video and do it. I am revealing this answer. For 30 you should see The factors are 1, 2, 3, 5, 6, 10, 15 and 30. And for factors of 42, you should see 1, 2, 3, 6, 7, 14, 21 and 42. These are the factors of 42. Did you get them? And for factors of 64, because it's a perfect square, that is 8 into 8, so it should give us an odd number of factors. So here you can see 1, 2, 4, 8, 16, 32 and 64. It's the odd number of factors, 7 factors. So did you get this? If so, it's a great job. Let's do a quick recap of whatever we have learned in this topic. First, we learned about equal division. Factors divide numbers cleanly with zero remainder. And second topic was factor pairs. Always use factor pairs starting from 1, so you don't miss anything. And third is nothing but prime versus composite. Prime numbers have 2 factors, whereas composite numbers have 3 or more factors. And next, perfect squares. Perfect squares always have odd number of factors. And lastly, factor bounds. Smallest factor is 1, largest factor is a number itself. So you did fantastic today. You have officially mastered factors of natural numbers. Make sure to hit that subscribe button, leave a like and click the bell icon so you don't miss a topic. In the next chapter, we'll learn about factors of algebraic expression. So I'll see you in the next video.